Alrighty, let's get this show on the road. What's up, everybody? The Network Berg here. Welcome to another live stream where we talk about networking and MikroTik and FortiGate and Cisco and all kinds of stuff, but mostly MikroTik because I find it easier to just lab certain concepts on the devices because it's so easy to get the software images. Anyways, I hope you guys have been doing well, and yeah, we're gonna dive into a few things. I think Nicola, who's actually on the stream quite a lot, asked me about a few things like how to set up VRRP using VLANs, and also wanting me to elaborate a bit more on management networks for certain ISP networks if you want to monitor your links or manage your equipment. And I figured it would be quite fun to play around with those concepts, and we're gonna dive into that actually. What you see behind me, that this hasn't anything to do with this video. Maybe we can do some stuff on here, but I'd like to actually make just a dedicated YouTube video regarding BGP instances and redistribution of routes. Even though I've already got something similar regarding redistribution, but maybe just a bit of an update could be fun. All right, so I'm just going to shut down all of this equipment. And then what I want to do is just go into my bigger lab so that we can actually play around with the equipment there. I don't know if I've got VRRP configured on the bigger lab. Maybe let's just configure it anyways. So I'm not going to go into the redundancy lab. I'm just going to go into Network Berg Stream Lab, which is that nice big lab that we made that's got all kinds of routers and firewalls and switches and MPLS and BGP and everything is in here. So this is a fun lab, which I did make available to some of the members of the channel. All right, here's the lab. Let's just zoom out a bit and let's just start up our nodes. Don't know if I want to start up everything, but let's start everything up just in case we want to add some stuff somewhere. All right, stuff is getting up. We'll take a little bit of time to just boot up all of the equipment. While that boots up, let me think about what we want to do with the VRRP. I might do something with one of these CPEs at the bottom. Let's just zoom in a little bit again. So just for people that don't know the layout of this network, this is like an ISP network we built, and from this ISP network we were delivering some services to customers. This top customer was like a fiber customer, and these bottom customers were like wireless customers. And what we've done essentially is put them in their own VRFs, and what we want to now try and do besides the VRRP is also just have a way for this router, which is router 6, to share all of the connected routes in a management VRF so that it makes it easier for us to manage the devices and also monitor the links and whatnot. Hey Tobias, hope you're doing well. Okay, so I think let's first start with the VRRP because that is actually a pretty simple thing to understand. And I might do it to the router that I've got BGP configured with, because this might make for some interesting setup. But I might need to just bring up another router besides router 6. Let's add another router, another node. Because the thing with VRRP is you want to have multiple nodes. You want to have two separate pieces of equipment in case the one equipment fails, then the other equipment can take over. I might not put it in the ISP network, even though I'm running a similar thing in some of the networks I manage, where my PEs have VRRP, and if one of the PEs fall over, then the other PE can just take over and start routing traffic. I just don't want to get too mixed up with the configuration on the core network side, because there is going to be a little bit of work to make that work. But we can achieve kind of the same thing just by putting in another CPE for the customer. And then this customer will basically have an IP address that will be connecting to our router 6 for us to establish BGP connection to. Wow, so we're also actually doing BGP. Sick. Okay, let's add another MikroTik. There you are. Going to use 6481. 12 ports, even though it could have stayed on 4. And just a router. I'll call this CPE10 VRRP. And let's apply this. And then I need to find this node I added. There it is. All right, so this node, I'm just going to put it next to the original node. And then what we need to understand is with VRRP, and this is kind of why you would have done this from the core, but I'm just going to throw it onto the switch, put it on a different interface quickly. Both of them will connect onto Ether 1. And let me add another switch as well, just for the customer computer, so that we can also just emulate some stuff with the VRRP from the customer's network. So this will be pretty straightforward. Let's take a Cisco IOL image, layer 2, because it's a switch. Let's make it a nice little switch icon. That should do it. And save this. All right, and now I need to find the switch. That's a pretty big switch. Hang on, I want to make the image similar to the other one. There we go, that looks nice. That switch was extra long. All right, so we're gonna have a switch, and then this switch will now essentially connect to both of the CPEs, to both of the routers as well for the VRRP, because we're gonna do VRRP on 2 perspectives, one being to the customer's LAN and the other being to our provider network. And you'll see why, because this is actually pretty cool. I'm just going to put Ether 2, oh no, Ether 2 of that MikroTik I want to move. Reason being is when you do stuff like VRRP, you do want to make your config match as much as possible. Even like how you connect the ports, you want to make it like Ether 2 on both of the routers connect onto the switch, just so that you like have a idea where what is, should there be some type of failover scenario. All right, so I'll put both of the Ether 2s on the switch. And then I'm going to just add this VPC to the switch. And there we go. And this is a very dumb switch. It doesn't have any config, and we're not going to do any config on this switch here. I might do some config on this switch up here for a VLAN, because maybe we're just going to span the service as a VLAN to CPE10. Maybe we're already doing that. Let's go check. So I'll just connect onto Ramon of router 7. Admin blank. And then from Ramon, I should see my CPE. So CPE10, it's the very first one. Let's connect. And let's quickly see what's happening here. Do we have any VLANs? No. Do we have any addresses? Okay, we've got IPs. I don't have BGP to this peer though. That's fine. You know what? We'll configure BGP from scratch as well. It's going to be super quick anyways. All right. So first thing I want to do is on the CPE10, we've got these IP addresses bound and all that cool stuff. So on CPE10, I just want to replicate the configs, not completely across. It doesn't even matter because we're going to use VRRP for both of these interfaces. So essentially with VRRP, you will have a live IP address on both routers that's in the same subnet. So let's say the IP address bound on Ether 2 that's going to the LAN instead of being .1, because I'm going to make .1 the VRRP IP, I can still give it an actual IP address in this range so that I can manage the router or the router, so that I can get to the equipment, so I can see if it's up and working, all that good stuff. So I am going to just change the IP address for CPE10 to 192.168.0.2/24 on the LAN interface, Ether2. And the network I'm not going to change. I'm going to apply that. And I'm just going to move Winbox a little bit here, because I'm going to bring in the other router here on the right hand side so we can work on them together at the same time. So let me just quickly enable Ramon so we can do this more easily. No. System identity set name CP10-VRRP. And then what I can do is tool Ramon set enabled yes. And that's all I'm going to do right now. So the rest of the setup we can do via Winbox. Let me go to my neighbors, connect here to Ramon, find the CPE10 VRRP and connect. All right, let's put those routers next to each other so it's a bit easier for us to configure. Let me also just zoom in on Winbox so it's maybe easier to see what I'm doing, because I know for some people the resolution is like too small, I guess, if I'm using Winbox. That's also kind of why I prefer the CLI. It's a lot bigger. There we go. Okay. So what we want to do is just also bring IP addresses across. So I'm just going to add an interface IP now as 192.168.0.3/24. So .3 will now be the router's LAN IP on Ether2. And just to see if it's working, we can just ping between the two routers quickly. So I'm going to ping 192.168.0.2. So I'm getting a response from router 1 or the primary router. Great, but now we don't have any VRRP or anything working yet. So to get the VRRP just working as a baseline very quickly, we're just going to go into our interfaces. We're going to add a VRRP interface. We can give it a name, but I'll just leave this as VRRP1 for now. Or let's give it a name, VRRP LAN. Let's call it that, so that we know this is the LAN network's VRRP. Then we need to go to our VRRP tab, and then we can specify which interface do we want to use. So I know Ether2 is going to my LAN, so I'm going to use Ether2. My VRID needs to be the same on all of the, well, of the devices or the interfaces that you want to participate in VRRP. You can leave this on 1, but it's good to make it unique for each VRRP pair as well. But I'll leave it on 1 for this, and then you'll see me make the ISP one maybe 2 or 100 or something. Priority, quite important. The device with the highest priority will always be the one that takes preference. So I want router 1, which is the left side one, to take preference. So I might make this priority 200. And the rest of the settings I'll just leave the same. And then let's add VRRP on router 2 or the VRRP router. The name is VRRP LAN. Did I make it a dash or underscore? Okay. Like I said, but it doesn't have to be the exact same like match like as a name on the routers. It won't cause issues if you accidentally make that a hyphen and the one is an underscore, because both routers are still individual routers. They're not like in HA or sharing configuration or anything. It's literally just two routers, but one of them has a floating IP that is active at any given time. All right, so let's add the VRRP. It's Ether2. Our VRID was 1. Our priority I'm going to leave as 100 here, or I can even make it 50. And I'm going to just apply this. Our VRRP interface is red, and that means it's not working at the moment. And the reason it's not working is because there's no floating IP address assigned yet. And also I can't say also because we have already assigned the network range. So we're actually good on that portion. If you also don't have the network range specified, then it's also still going to cause issues with the VRRP itself. But let's add the floating IP now. And to do this, it's very similar to just adding another IP address. We're just going to hit the plus. And our IP is going to be 192.168.0.1. But I'm not going to do a /24. I'm going to just leave this as a /32 address. And now I'm going to bind that to my VRRP LAN. I'll apply this. And you'll see this IP is now red. But if I go to my interfaces, you can see it's actually doing something with the VRRP. It was a B for backup, and now it's switched to RM, which makes it the running master. It's actually the active interface now. If I look at my addresses, I can see this address is now black, and it's actually working. If you are running, like you'll see in a sec, if I add the VRRP on the right router, how this works exactly, but it's pretty straightforward if you think about it. Like there's going to be one live IP, and this will be the IP that we use as a gateway. So let's just add 192.168.0.1 again to our VRRP LAN. And then the important bit that I want you to notice is, again, this interface is now backup, but whenever the VRRP interface is a B for backup, your actual IP will be red for the floating IP address. So I just want to go into Eve quickly. Let's go into this VPC. And let's just set some gateways. So we can do an IP, let me just do a question mark, IP 192.168.0. Let's make this 100/24 with the gateway being 192.168.0.1, which is the VRRP IP, the floating IP address. So let's quickly see, can I ping 192.168.0.1? I can. So I know that that IP address is live on the network. It's actually working. I wonder, is the internet portion working? No, it's not. But that's because of some other stuff here, but that we're not going to try and fix now. What I can try and fix or do though is see, can I ping 192.168.74.2? Alright, that is failing at the moment. I just want to have a look at MikroTik 10 quickly, or CPE 10. Just want to see, do I have masquerade rules quickly? I should. Alright, I do. Okay. That's totally fine. What I'll maybe try and ping is just the IP address on my provider network, which is 10.201.0.1. So let's just quickly see, can we get there? Because that will tell us there is actually some form of a way to get out of the network. Ping. Yes, so I can ping my router 6, which is my provider edge for my ISP network. So traffic from these routers can now get to router 6. But this is technically just CPE 10 that's working. So let's do the rest of the config on the other router just to get everything in line. I just want to make sure, ooh, that's going to be an issue. So if we work with stuff like VRRP, we need to make sure that we have enough IP addresses available, because VRRP, you want one IP address that's a floating IP, and then we also want to add some IP addresses to our actual other devices. You saw, like for Ether2 on both of the routers. Now, if I only have a /30 subnet, that means I only have 2 usable IP addresses that I can use for comms, which is fine for point-to-point. I mean, you could use a /31 for point-to-point as well, but this will not allow me to use VRRP. So I'm just going to update this IP addressing for the WAN to something else. I just want to check what we can make it. So I've got 10. So .8 is the last one. So I can actually go from, let's just see. I might have to start from .16. Yeah, I'm gonna have to start from maybe even .16 we'll have to start from. Alright, that looks fine. Alright, so what I'm going to do is just quickly update the IP address that's going to the WAN. to 10.201, and we can leave it as 0. So I said from 18. So 18 would be the network. 19, I'm going to make the VRRP IP. So 20 will be my router's IP. And then I'm just going to add an address as well on the VRRP router, but as .21 on Ether 1 now. All right, that's perfect. And I just quickly need to get onto that switch as well and tag that VLAN on E11. So show VLAN. Let's just see, to CPE 10. I've got VLAN 1030. All right, so all that I'm going to do is config t int E11 switch port mode access switch port access VLAN 1030. Okay, let's just see, show MAC address table VLAN 1030. I'm not learning that MAC address yet. E00 and E11. Show run E11. ET11. Let's just check it like this. E11. All right, so that is right, and that is right. I might just have to do the whole annoying cable cable delete and reconnect. Let's try that. Hey, I don't want to move you. So Ether 1 goes to E11. Jump back onto the switch. And let's just see, am I learning other MAC addresses yet? I'm not. All right, let's just try something. Let's check from the routers. Can we just see if we can ping towards each other? Winbox. All right. So let's see. From the VRRP router, or I'm just going to reference it as router 2 the whole time. Can I ping 10.102.0.20? It says no route to host. Okay. My dyslexia got the better of me there. All right. So we can actually ping the WAN IP of the primary router. Let's just see, I might just have to update the IP on router 6 quickly. So let's just do that as well. So connect to Ramon, find router 6. And then I'm just going to find the thing going to here, to CP10, and then I'm just going to update this IP. So I'm going to make this dot I think I said I'm making dot 17, so let's make it dot 18. And let's apply that. And then all that I want to see is, can I ping 10.201.0.20? And I think those were the wireless customers. Wireless customers. Okay, that's failing to the .20 IP. Let me just ping it directly. All right, it's not liking that. I might have to delete this cable as well. That was E01, I think. Of course, I lost connectivity there. See, can I reconnect? Yes. And I just need to reconnect on both routers. Come now. Let's just go to our Roman neighbors. Is my CPE10 here? No, it's not. Just disconnect and reconnect to the Roman quickly. There we go. Connect. Alrighty. So let's see. Can I ping 10.201.0.18? No. Did I put that in a different VRF? Let's just maybe check on router 6 quickly. Let's look at our IP routes. Go into our VRF. No, it's definitely here on the fiber customer or the wireless customer side. Do I have the right address? Yes, I do. So ping 10.201.0.20. Routing table wireless customers. Oof. Let's just first fix this, because I really want this to work for us to do the VRRP with the BGP and show you how cool that is for some failover process. Let's just jump to router 2 as well. So that's 10.201.0.20, which is right. Alright. This should in theory work. I really don't see anything that's out of the ordinary there. Just go into our interfaces. Let's just maybe give it a good... It shouldn't be that though, because I am able to get there over layer 2. The VLAN is being learned and all that stuff. So this is definitely a layer 3 issue with either a route or some other thing that's happening. 1030 CPE 1020 meg, that's fine. Routing PGP VRF, that stuff's fine. Oh, so I had the peer to CPE 12. Hello. How are you doing? All right. Connect again. Let me just reconnect to the neighbor quickly. Router 7, connect to Roman, find the CP10. All right. And that is on Ether 1. Ether 1 does go to our switch. Alright, we're learning the MAC addresses, which is fine. I'm doing good. A little bit tired, but I'm doing good. My fiance and the baby, she took to her mother tonight, because the mother is, or the grandmother, you know, they miss the babies a lot. So it gives me a I guess more quiet in the stream, but I won't lie, I'm missing the baby a lot. You know, if you're a dad, it's crazy. Okay, that's not what we want. Like, this is literally just an IP address, and I should be able to ping it. Let's just see, do I pick it up in my neighbors? I do pick it up in the neighbors. Let's just try and ping it from the routing table as wireless customers. And that's just timing out. That's so weird, because it's definitely not what I'm expecting. Let me maybe just remove that IP. And I'll just assign a new IP, like straight. Was it still set to /30? Sorry, I didn't even check that. If it was set to a /30, it makes complete sense why it wasn't working. 10.201 018/29. And that should be on our VLAN 1030. But I actually think you're right. If because I really didn't check like if it's a /30 or not. Let's see. We can go back here and just look at our neighbors and see if we can ping across. Ping from the right VRF. Yes, it's working. So that was definitely it. I mean, that's me having a brain fart. All right. So if we have the layer 3 connectivity up and running, that means both of these routers can now talk to router 6 on VRRP as well. So I just quickly want to set up the VRRP to router 6, and then we're going to test some stuff with the VRRP from the LAN and how to get across and all that stuff. All right. So first things first, I'm not going to do any configuration on router 6 now. This is all going to be in the CP. But this type of VRRP failover you will see a lot on an ISP network. They will put this up just in case there's some, you know, a bit of a routing problem, or let's say a hardware problem even. Like that's a better way to describe it. All right. So let's add some more VRRP stuff. Oh, but wait, I actually want to change this ports from access on the switch. I want them to run as trunk, and I want to span a VLAN across quickly. So let's do that. So what we're going to do is config T, interface ET11, no switch port mode access, no switch port access VLAN, switch port do show run ET11. Oh, do I need to actually go out? Show run int ET11. Alright, that interface is perfect now. I need to do the same for, what is that? E00. So ET1 or 00. No switch port mode access. No switch port access VLAN. Okay. So we just want to convert those interfaces to, let's say, trunk, so that we deliver the service as a VLAN and not necessarily as, you know, an access. It's just so that we'll have to tag the VLAN on the CP instead of it just plugging into the port and working. So let's do switch port mode trunk. It's going to complain, so let's do switch port trunk encapsulation .1q. Okay, now we can add that, and I'm going to do the same on ET1. I'm on ET11 or no, ET00. So ET11, set the encapsulation, set the mode to trunk. Let's just maybe specify the VLAN. So that was 1030, and I'm going to do the same on Ether00, and that should be it. So we can write that, and let's just see, show VLAN 1030, or let's do a brief, show VLAN brief. Okay, let's quickly check if I go into my devices. I might see, okay, I'm gonna have some errors there now, but the reason is quite simple, because I actually don't have the VLAN tagged on the interfaces now. So let's just quickly add these VLANs to our MikroTiks. So admin blank interface VLAN add VLAN ID 1030 name WAN, and then we can set the interface to Ether1. And this config's literally going to be the same on the other CPE. So the VRRP CPE, so let me just add that. And let's just check, can we see any neighbors? I can see something on Ether1. There is WAN. Let's see, can I ping WAN? Alright, that's giving me some timeout. Let's check on... Am I still on router 6 or not? Yes, I am. Okay, great. So on router 6, those are now just the straight interface ports. So 1030. What I might do is just use the service tag, seeing as how I am using that Cisco switch in the middle. So I might make a slight change here quickly. So interface VLAN set use service tag yes. And if I do an IP neighbor print, do I see anything now? No, I don't see anything. Interface VLAN print. Alright, but I was getting a neighbor back just now. And I think I had this issue in a previous lab as well. And I definitely want to deliver the service as VLAN. Just give me a sec and let's just jump onto a few others of the CPEs. I just want to check, did we ever add VLANs to them or not? So let's connect to the ROM. Let's find CPE 11. Now this is pretty blank. And what about the other CPE 12? Or was it 13? Let's just check. So 10, 11, 12. So let's connect to 12. No, I don't span any VLANs here. Because the whole point is I want to actually show you something with the VRRP on a VLAN scale. Let's just check from the Cisco switch quickly. This show MAC address table VLAN 1030. Alright, so I am learning MAC addresses, which is good. And it is on the right interfaces. So let's go back to our router 6. Ether 3, that's fine. We're using a service tag now. But now I can't see any of that stuff. Alright, let's just disable the service tag quickly. And I'll do this on the normal CPE 10 as well. So interface set service tag no. And let me just check on my neighbors now. So there I do have a neighbor coming back. And that looks fine. And I can MAC ping it as well. IP neighbor print. Did I ever move the IP address? Because that's actually the issue, I'm pretty sure. If I do an IP address print, my IP is still bound to Ether1. Okay, so that is our issue. IP address set. Let's just change this interface to WAN on item 0. And let's see, can we ping 10.201.018? Yay, we've got liftoff. Let's just do an IP route print. So what we'll do is the route will just update as well. So IP route set the gateway we just want to update quickly. And this gateway is 10.201.0.18 now for item 0. And I want to just look at my masquerade rules, IP NAT, IP firewall NAT. Just export that quickly, because now we're NATing traffic out of Ether 1, which is not the WAN interface anymore. We're just going to IP firewall NAT set out interface. It's going to be that WAN that we connected. All right. So I feel like the configuration on CPE 10 is done. We just want to replicate most of this config onto the other CPE quickly. So we can do this by jumping onto its command line, and we will continue the setup via Winbox. All that needs to happen is I need to add the VLAN quickly. So interface VLAN print. I've got the VLAN already, so IP address print IP address set interface equals WAN for item 2, and an IP firewall NAT add. Our chain is source, our action is mask, and our out interface is now WAN. Cool. IP address print. Now we get to quickly Winbox back on the 2 CPEs so that we can continue the VRRP setup from a WAN perspective. So let me see, can I connect to Ramon here? Doesn't seem to like that. Let's just reconnect to Ramon completely and connect to the VRRP one as well as the other one. And I seem to have closed that Winbox session. So let me connect to Ramon and connect to CPE 10. Let's move them back in a spot where we can see them nicely. And if we see, we've got our VLAN interfaces now. So let's just go to the interfaces completely so we can see where what is. So there is a WAN interface. And what we're going to do is for VRRP on a VLAN, it's very, very simple, very straightforward. Nothing changes to how we just set it up. It's just instead of using the physical interface, we're going to be using the VLAN interface. So let's go to our VRRP, or we can just hit the plus here, find the VRRP here. And the name I'm going to give this is VRRP LAN, or WAN, sorry. For our VRRP, the interface, we're going to set this as the WAN interface now. My VR ID, I might make 100 now. Our priority is going to be 200 for the main router. And I'm not going to change anything else just yet. Cool, now you'll see I've got a VRRP interface underneath the VLAN. And I'm going to do the same now on the VRRP router or the second router. Add a VRRP. Call it VRRP WAN. Select the interface as the WAN interface. Make the priority lower. I mean, I could make this 10 now. It doesn't matter. Again, like the stuff doesn't need to match exactly, just as long as you know like where what is. Like the thing with the lowest priority will be the slave. The one with the highest priority will be the master. Let's apply that. And our stuff is red because we haven't assigned the floating IP yet. So let's do that. We're going to go into our IP addresses and let's add a bit of a floating IP. And this IP will now be 10.201.0.17. We're not putting in the subnet now. And we just bind that to our VRRP WAN interface. And I'm going to do the same on the other router, the VRRP router. So 10.201.0.17. I'm binding you to our WAN. All right, awesome. Now in theory, these two floating IPs on the right hand router should be read, and the ones on the left router should be like not read. I just want to check why this one isn't read, because that's a bad sign. And this is showing me that the VRRP WAN is actually a master at the moment, which is bad for us. So we just quickly want to troubleshoot that and fix it, because if two devices is a master, it basically means that the floating IP address will be live on both of the routers, and that can cause what we know as a duplicate IP, which is bad for us. All right, so let's just fix up the stuff quickly. Let's just make sure our did I set the I feel like the VRID I made incorrectly. So let's just see what is the VRID on both. There we go, 100. So that was a slight typo, and that's probably the issue. But it could be if you have a layer 2 issue, that can happen as well. So just be mindful of it. Like, that's kind of the point. All right, this is now a nice backup, and if we go to back to our IPs, they should be read. So both IPs are read now, which means the .17 IP isn't live on our VRRP router, it's just live on the primary router. Okay, so I just want to test this quickly from router 6. I'm going to just run a ping to 10.201.0.17 from the wireless VRF, and I'm getting a response. Awesome. So the VRRP for the WAN is now working as well. Now let's start doing some interesting stuff. First, I want to test and see if the VRRP is actually working by disabling or killing like CPE10. So what we're going to do is on that VPC we were running, let's run a ping to 10.201.0.18, which should be the IP address of router 6, our provider edge. And can I run this for longer or not? See, hopefully -T. I just want to make sure it keeps running. Okay, good. So while that runs, all that I'm going to do is I'm going to shut down the CPE10. So let's just stop that. And let's just see, does VRRP kick in or not? It has kicked in. So I'm still getting to router 6, but now via the VRRP router. And it's important to note, if I ping 192.168.74.1, I'm still like, let's just see. Oh, I won't be able to ping that. I actually want to ping 192.168.0.1. So 0.1 was that floating IP address that we assigned. So that floating IP now has become live actually on the VRRP router. So if I go into Winbox and have a look at it, you'll see actually both of the IPs have gone black, which means they're active. They're no longer like in a disabled state, and our VRRP is now the master here. So these routers are actually now working in conjunction with each other for failover, and that's actually quite nice. So what I'm going to do is just start up CPE10 again. Let's see, let's run our continuous ping again. So ping 192.168.0.1 -T. And I actually think it's already back on CPE10. And we can do that by just connecting to ROM1 again. There's CPE10. I can already see there the master. And let's see on the VRRP router. It's back up again. Okay, so the VRRP from the LAN is working. And that's just on an interface level. We actually know that it's working on the WAN level as well, because we could actually break out and ping router 6's IP. So we were a bit advanced with showing you that. But now we can do the fun bit. So I'm just quickly going to add like some BGP peers to learn routing dynamically, and you'll see actually why this is so neat. So what I'm going to do is just add my peers, or let's add some instances quickly. I'm not sure what I want to make the instance. Let's just maybe make it AS 150. And this is now just on the CPE side. Router ID, this can be 10.201.0.21 for the VRRP router. And remember, the router ID you do want to make unique. So please don't, we could potentially use the VRRP IP, but I just recommend using a unique IP. All right, so let's just apply this. And I'm going to add the instance on the actual primary router as well. So AS150, the AS is 150, router ID 10.201.0.20, and apply. Let's quickly add some peers. So we'll just call this peer to R6, which is to the PE. My instance will now be that instance I just created. My peer IP, and this is what's really nice about the VRRP setup on a WAN level is you can use the VRRP IP as the remote address and things will work. So I'm going to use 10.201. Okay, but for this I'm peering to the the PE, which we didn't set up VRRP on. So, but you'll see in a sec. That remote address was .17. Remote AS. I just need to check what is the AS 65000. So we can make this AS 65000 for the remote AS. Let's maybe bring down this whole timer to 30 seconds. And that should be it. All right, cool. Let's also add the peer on the right router. Oh, there's one more thing I wanted to change, and that's actually in the advanced tab, our update source. I'm going to use the VRRP WAN as the update source. All right, let's set up the other peer to R6 instance AS150. Remote address is going to be 10.201.0.17. Is it .17? No, .17 is the VRRP IP. This is actually .18, I think. So let's just apply that. Remote AS 65000. Set the whole time to 30 seconds for this. And let's quickly apply. Oh, and set the update source as well, VRRP WAN. All right, now we have two peers from the CPE, but we want to obviously peer from router 6 as well. So let's quickly set up the router 6 peering. So we can go into our routing, BGP, add some peers. And we can call this just, I'm not going to add two peers. That's the cool thing. I'm adding a single peer to CPE 10. My instance will be my 65000. My remote address is going to be the VRRP IP, so 10.201.0.17. My remote AS in this case was 150. Make the whole timer 30, and let's originate a default originate. Let's apply this. And then let's see, do we actually get the peer to establish? I don't think I've set the update source, so let's just set that as well. So that is this one, 10 CPE 10 20 meg. Ooh, I actually think I have the wrong AS there. This should be the BGP wireless customer. Reason being is that's in a different routing table. There we go. So now our BGP peer is established, and effectively what should happen, let me just see, am I learning any prefixes? I'm not seeing any prefix there, but I don't think I've added any networks. So let's just quickly add the networks. on these routers. So the networks that we want to advertise is 192.168.0.1. And let's apply that and add it on both routers. So 192.168.0.1. Oh, I didn't make it a /24. So let's just update this to a /24 as well, because that is the LAN subnet. Alright, so if I go back to my router 6, now I am learning a prefix. I am learning 192.168.0.0/24. We can verify that by just looking at the received from routes. So that's quite easy to do. We just do an IP route print where received from. We can equals that, and we can say peer to CPE10. And then this will tell us what routes we're receiving over this BGP peer. If we do detail, we can see print. I think I need to put the detail before the where. We can see a lot more information. We'll see stuff like our AS path and the origin and all the nice stuff that you'd see if you're in Winbox. I can also just see it by going into Winbox, looking at my routes. And if I go into this wireless customer VRF, I'll see I am learning 192.168.0.0/24, which is nice. I wonder, can we ping 192.168.0.1 from the wireless customers? We can, okay. So the routes are being learned dynamically. Okay, now the fun bit for the VRRP. And remember, this is also running over a VLAN now. And what we want to effectively do is, let's say these are two different links. It doesn't have to be two different links. It can actually be the same link, but it is handed off over a VLAN. But this is why you won't really see this on the CPE side. I just did this on the CPE for ease of configuration. This is why you'd probably have two routers on the edge, and then both of these edge routers, you would remember you'd have like an access switch for your interconnects with your layer 2 providers, and then from them you basically have this VLAN on the switch, and the customer would essentially have one cable running to a router, and then they'd form the BGP peer to the VRRP IP at the PE actually. Now I'm just going to simulate to you what happens in this event. So you can imagine this the bottom is actually now kind of like supposed to be the PE. But what's going to happen is we're going to run our ping from router 6. So from router 6, let's just do a ping to 10.201.0.17, which was the VRRP IP for wireless. And we're getting a nice response. And also I just want to open up the... Why is my back so itchy? Don't you guys hate it when you get an itchy back? You want to show some stuff? Alright, so the other thing that I want you to see that's pretty cool is I'm going to leave the BGP peer open as well. It is going to drop, but it's going to reestablish as well. So what we're going to do is we're just quickly going to kill CPE10, just stop that. And let's have a look at our router 6. Router 6, the ping has continued. It's working still flawlessly. And then I want to have a look at what happens with the BGP quickly. So we're just going to wait a little bit. It might take a few seconds. Let's just see. Because I am kind of expecting this to just come up. But we did set that whole timer to 30 seconds as well. A little bit unfun to be waiting, but this is what I want to show you guys. Because in theory, your BGP peer should just reconnect automatically because it's connecting to a VRRP IP now, and the VRRP should just be taking over the session and your connectivity should start working again. Let me just go on to the VRRP router, look at those peers as well. So the remote address is correct. Just do this. All right, it has established. All right, both they are established. So the peer came back up, and the nice bit is I didn't have to update it manually. I didn't have to have two BGP peers. It's just a single IP that I'm peering with, and then should one of the equipment, one of the hardwares, one of the gears fail, life continues. Like, that's actually a really good way to hand off and do some good failover, because now we have multiple PE routers that's effectively doing the same thing. And then if we did somehow have an issue, we did a firmware upgrade, the router died, we'd have a way for our customers to still have connectivity. And it's so cool that it works with our stuff like the BGP, like OSPF, like anything. I love it. It's really nice. All right, so that is now effectively a little bit more in depth about the VRRP, because now we've set it up from base just as on a normal interface, which we did in the previous lab anyways. And also we did the VRRP with VLANs, so not just a straight interface. And we did something very cool with the BGP setup as well. And we did this all in an hour. Pretty cool. Damn, my second screen is off, so I can't even see the chat. So sorry about that, guys, if you're asking me questions. Hang on, maybe I can scoot the chat up somehow. Let me just pop out the chat. Damn, but I don't want you guys to all just see the chat either, because that's also not fun. I might just alt tab between the chat. All right. But again, guys, if you have any questions about the VRRP, ask it. Else I'm going to move on to the next lecture. And that is, well, it's not really a lecture. It's more or less just me messing around on Eve. But we're going to add something that we like to call a management router into our topology for the ISP network. And the whole reasoning behind why you are wanting to add a management router is the management router's role in the network is just to learn routes for management purposes. This is more catered towards ISPs again, because you want to learn your connected routes for your links so that you can add these links to monitoring, and effectively your management router or management VRF would distribute routes to your network so that you can do your monitoring, so that you can do your configuration or remote management without it being a big hassle, without doing stuff like the mangle rules I did last time, or by creating BGP sessions for a management VRF to span it across all of the devices. Now, this is still going to be a bit of setup. It's not just a quick thing to just bring up, boop, it's there. I think router 2, I made a route reflector. Is there any router in here that we can just use as a management router maybe? Router 1 looks pretty good. Let's just quickly get onto router 1. I just want to see what it's doing, if we are delivering any kind of service on it. If not, that's going to become the management router. That's router 7 I'm on, which is that edge or the ASPR. Let's find router 1 and let's see what this bad boy is doing. No BGP, wonderful. It should have some OSPF for our backbone network, which is also good. All right, so this basically is just like a provider router not doing anything. Perfect for us. I might just have to reconnect onto Ramon quickly. No, connect to Ramon. Find router 1, connect. All right, so the reason why I bring it up is it's pretty easy to manage a router if it's just a router, right? Hang on, let's maybe go to draw.io. Save diagrams to decide later. All right, let's just bring up some networking gear here. I might just use Cisco, and the AWS stuff is actually quite nice. I haven't seen Azure stuff yet. Let's maybe add that as well. This is just to see the icons for draw. All right, they have some pretty nice arrows and all that stuff. Okay. So let's just find some Cisco stuffies. Or wait, can I search for a cloud here? Cloud. Here's some nice clouds. Amazing. And I might take a few more clouds. Let's just use the same type of thing. So maybe you're wondering, what the heck is he doing with all of these clouds? But it's going to make sense as soon as I actually, 3 of them should be enough. So essentially what I'm going to do is I'm just going to, can I make these just lines? Plain lines would be nice. Does it have to be double? There's a single line. Let's just remove the arrow. Okay, that actually didn't look as nice. Let's just delete. Put that somewhere else. So this is just me trying to explain to you what a management network is all about. So this big cloud is kind of going to be your management VRF. How can I add some text here? Title, management VRF. And let's just duplicate this, and we could call this customer 1 VRF, customer 2 VRF, and customer 3 VRF. I think I've only got the 2 VRFs, namely being fiber and wireless, but this is just to explain the concept. I'm not gonna like add another VRF on our network now just to get the point across better. Let's just put that there. So our issue with VRFs is your routes and stuff is limited to what's inside your cloud. And the only way that you could potentially learn like a management network's IPs and how you could also distribute your IPs to a management network is by using stuff like the route distinguisher, route tags, and all that stuff. So what you'll find that some ISPs do is they would add the management router into the network, and effectively what happens is these routers where these customers VRFs or their routing tables exist on, you would form an OSPF relationship with a management router. And this is not just for MikroTik, but they might use other IGPs, maybe like ISIS or whatnot, in order to learn the routes to the management router. But the nice thing is, from the management router, you can also send out routes back to them via the OSPF, and you could send all of the routes that the management router is learning to the rest of your network or your management network or whatnot. So this is going to make sense the moment we add this. All right, let me just look at the chat quickly. L2TP versus IPsec. So in theory, IPsec is more secure, but L2TP has a much better use, especially in the ISP world. Reason being is whenever you configure an L2TP interface, that L2TP you can actually bind into VRFs. You could actually add it as a remote site for a user, put it in a different routing table. So, I mean, you could do the same with like a PPTP interface and stuff like that, but not really with the IPsec, because the IPsec just works on, I think, on the main routing table of the router, and there's some tricky stuff that you need to do to make everything work. But technically IPsec is more secure. L2TP I would use in an ISP environment if I want to add remote sites into different VRFs and whatnot. Okay, so let's just get back on topic here, and I'm going to just jump onto the network again. I hope the explanation is sufficient. But what we're going to do now is, and I'm not going to do a lot of config on all of the other routers. For now, I'm just going to set up connectivity. Like OSPF is already there between router 6 and 1, but maybe I want to do something else. No, it's fine. We can use router 1. So router 1 is effectively just going to be a router that's going to learn all of the OSPF routes. That's it. So that it builds its routing table, and then we can piggyback off of its routing table to get to everything. So instead of having to span different VRF sessions between all of the routers to learn that management network and whatnot. Okay. Now what I want to do is I'm going to go back to router 6. And the first thing we want to do is add some stuff for the OSPF. So I'm going to go into my OSPF, but what I'm going to do is actually add some instances. So for each, let's say, VRF that the customers are using, I'm going to create an instance for them. So I might call this OSPF wireless customers. And the router ID for this, I'm going to make, I obviously can't make it 9991 because that's being used by something else, but I could maybe think of some new IP address scheme between these routers. So let's see, I've got 10.2550 whatever. Where did we end? At 7, it seems like. All right, so let's duplicate that, and then we're going to add another let's say address between these devices. And we're also going to have to add some stuff like VLANs. Like I said, the end goal is it will make your management a lot easier, but you need to set the stuff up, and that's also what like scares people and isn't nice and isn't fun, and it's iffy if you don't have it up yet. But once everything's there, it works perfectly. I might use some unconventional IPs here for this. So I might use something like the 172 range. So let's make 172 30.0.0. And let's just give it a, yeah, let's make it /30 since this is actually just point to point at this stage. And then I'm going to go into here. So I said 172.30. Let's make router 1.1, and then router 6 will be .2. So that will be the router ID for router 6. And now here, this is kind of what makes the magic work, is we can redistribute our routes that's in that routing table. But let's specify the routing table. So we've got various routing tables. We've got a routing table for our wireless customers and for our fiber customers. So I'm just going to set that for my wireless customers. And then here's the weird thing. Use DN. We're not going to use the DN, but I'm also not going to click anything there. I'm just going to leave that blank. It's a weird thing I've picked up on MikroTik. Sometimes if you don't like do that, the routes don't advertise properly. Actually, let's just leave it as the base and let's see what it does. But I've had issues. Sorry, my computer screen keeps flashing now. I need to maybe consider looking at what's happening with my computer, but I'll do that after this stream. let's just say for this routing table, for this OSPF instance, we want to redistribute our connected routes, and we might want to redistribute our static routes, and you'll see something else we'll do in a bit. And I'm going to apply that. That's it. Easy as Bob. I don't know if I've heard that saying a few times. I don't know if that's an actual saying overseas, but yeah. Hey, Wolfbit. It's up to you. Look, if you use L2TP with IPsec encryption, then that's super secure. And that's probably more secure than just IPsec. But remember, there's going to be a lot of overhead on your packets and such. All right. So what else we're going to do now is go back into our networks, and let's just advertise the networks along. Actually, we want to set some areas as well. So this is not going to be on the backbone. Let's say each VRF we can actually put in their own area. So what I'm just going to do is call this area is going to be for our wireless customers. My instance will now be that OSPF wireless customers that are added, and my area ID I can make 0001, and I'll leave this as a default. I'll apply that, and there we go. And then if I look at my interfaces, it should already have interfaces, but my issue is I haven't added the IP address yet, so that's why it's not kind of working. We probably want to also just create an interface that's in that same VRF, but this will just be on router 6. On router 1, we're not going to add that VRF or anything. You'll see, and it will make sense as soon as the setup's done. So what we're going to do is we're just going to span another VLAN, and that VLAN is on Ether 1. And I might just make that VRF wireless customers. My VLAN ID for this, I can make 100. I can make it whatever I want, as long as it's in that 4096 pool. And let me bind that to Ether 1, apply that. And let's quickly add our IP address, which was 172.30.02/30. And that is going to be on my VRF wireless customers. All right. And now I just need to add that interface into my wireless customers VRF. So VRF wireless customers, apply that. Let me just see if there are any chat questions quickly. Oh, I closed that. Let's just pop that out again. I know this looks funky. I don't like seeing like the screen analytics. I actually don't like looking at it while we're streaming. I just want to be able to see the chat if any of you have questions. All right. So next bit. We just want to also add that VRF VLAN on router 1, which will now be the management router. I just want to check our OSPF if the interfaces has been added. No, it hasn't, but I don't think I've added the network yet, so let's just add the network. And our network in this case is 172.30.00/30. But my area for this will now be my wireless customers. And now I should see my VRF wireless customers is now also participating in OSPF, but this is now in its own area. Pretty cool. And then what I'm going to do is jump onto router 1. I think I've got it open here. Yes, I do. So then first thing we want to do is just also add the VLAN on router 1. So this was VRF wireless customers. Our VLAN ID was 100, and this is that Ether 1 as well. I just want to make sure. Yes, it is. So ether1, can apply that. Let's just quickly add our IP address. So IP address 172.30.01/30, and we're binding that to our VRF wireless customers. And see, I'm not going to do anything with the routes here. I'm not going to add VRFs or anything here. Like nothing gets updated or changed here. It's going to be the same now for when I go into my OSPF. But the OSPF, I'm still going to add the area. Like that's the important bit. So let's go into our OSPF, go into our instances, add an instance, call this OSPF wireless customers. Router ID 172.30. This is 0.1. I'm not going to redistribute anything here. Like there might be something we redistribute, and that would be a management network range, and you'll see in a sec. But for now, I'm not going to do anything yet. And I'm not going to set any routing table or DN, all that stuff. This is just me to be able to connect on OSPF. So we've got our instance. Let's add our area. But again, the area is wireless customers. My area ID was .1 at the end for the wireless customers. And I'm going to set the instance as the OSPF wireless customers. Apply that. And now I'm going to add my network as 172.30.00/30 with wireless customers as the area. And if I look at my interfaces, the interface is up, and it's actually gone up. This is now the backup. I might want to change this though. So let's just copy this. I might want to set the priority to 20. Let's just see what it does. Still backup. Also maybe on the OSPF on router 6. Let's just maybe change the cost to 100. All right, so now router 1 is the designated router for for that. But again, this is now the management router. Like I'm not adding any of the routes here. Like I'm not adding VRFs and stuff. But what I want you to take note of is I'm learning a bunch of OSPF routes now. I'm learning the routes from router 6 for its interfaces for the wireless customers. Like I can now kind of use this router in order to get to all of those WAN links over the interfaces. So in theory, from my management router, I might, let's just see, can I actually, wait, let's go to router 6. I just want to have a look at its routing table. So on router 6, if I look at my wireless customers VRF, I'm actually not learning any OSPF routes. And this is where we kind of want to inject a management route into the customer VRFs. So to do this, we can just go into our, there's two ways we could go about it, but I could essentially just do something like in my instance, I could do something maybe like have a route here, or I could just specify that in the networks quickly. So let's go into our networks, and I could just specify I want, because let's say 192.168.74.0/24, that is my management range. And then I just want to check quickly on router 6, am I learning that range now? I'm not, but it's red here as well. But I've got a suspicion why it's red as well, because there's no actual routing for it in the routing table for the management router. So let's just see here. What we could do is, well, there is a DOA there. Let's remove that route quickly from the OSPF. So let's remove it from the networks. And then what I want to try and do is in the instances, let's just redistribute other OSPF routes as type 1. And then if I go to router 6, I'm now learning a ton of routes. And I actually don't want the VRF wireless customers to learn all these routes, because this is nothing to do with their VRF. They shouldn't have to know how and where to get to everything. So what we could do to effectively stop that from happening is we can go into our filters. We can add a filter or a chain. I can call this MGMT out. So this is a chain for all my management stuff out. And I only want 192.168.74.0/24. That prefix, that is the only thing that I want to accept. And then I'm going to copy this rule. So I keep the chain. I'm going to remove the prefix. And I can discard anything else. Another thing we could do to potentially make that a bit simpler is just hit the plus. Add a chain. Let's call this MGMT out 2. And then what I could do is add the prefix. And then I could just say an inverse rule to say anything that is not 192.168.74.0/24 to be dropped or discarded. All right. So let's just see what the impact is. So what I can do is go into my routing OSPF, and then inside that instance, for the out filter, because remember these are routes that I'm sending out, let's just add this as the MGMT out, apply that, and let's jump back to router 6. And hey, now I'm learning my management route from OSPF so that my management network can now get to all of these connected subnets here in this VRF. And likewise, my management router now is learning all of the routes. So if I've got a different management VRF, I could be sending that through to that management VRF using the OSPF as well. Or if this is all just on my main routing table, it will work fine as well. Because what I could do is maybe, just to show you if it's working, but I might have to, okay, I'd actually have to add that IP here. So I'm not going to do that. Route print. Let's just see, do I have any routes for 10.201.0.star? No, I don't. So let's just quickly add a route add. I don't know if I'm running this as admin. Let's just quickly make sure, else I'm gonna feel pretty stupid. So let's do a route add. The destination is 10.201.0.0. The mask is 255.255.255.0, and our gateway will be 192.168. Let's make it 74. Let me make it .40. You're going to see why, because what I'm going to do now is I'm just going to add 192.168.74.40/24 on Ether10 quickly. And then what I'm going to do is let's just add my management network. And remember, this could have been another site, the DC, wherever, where my monitoring software and stuff is located. So I can add my network, add it as a management cloud. There's a management computer. And this management computer is now going to connect to the management router on its Ether10. And now the awesome bit, and this should work, is in theory I should be able to get to 10.201.0. Let's try .20. I can't get to .20, but let's try .17 maybe. Can't get there. Can I get to .18? Can't get to any of that. So let's just see why not. Let's just check from router 1 quickly. Can I actually ping 192.168.74.2? Yes, and .1. Can't ping .1, and that should be my nick. I just want to check on my route print. 10.2010 star. I did make it .40. Let's see, can I ping 192.168.74.40? Yes, I can. So if I can ping it, I should actually be able to make it work. Let's just see why this is potentially not working. So we're learning all of the routes here. And this is just in the main routing table. And here we are learning 10.201.0.16. And we're also, there's a directly connected route for our management range here now. So let's check on router 6, which is actually important now. So from router 6, I'm not learning my OSPF route here now, which is bad. It's going to cause issues. Let's get back onto the management router quickly, just the routing OSPF. I might just change this filter to the MGMT out _2. And I'm still not learning that route. Let's just look at something for the OSPF quickly. Is my instances running? Yes. All my stuff there is up. Oh, okay, I have an idea why it's not working. So let me just go back into router 1. And then from router 1, in my instance, I just want to check my OSPF wireless customers. Because before I was redistributing that route as a other OSPF route, but since I've configured this as a directly connected route on the router, I can't learn it because it's just a DAC now. So let's just redistribute our connected routes as well and go back to router 6. And there we go. Now we're learning our management route again. So let's do our test again. Can we ping 10.201.0.18? We can. Can I ping .17? We can. This is amazing. All right. So technically now what's happening is all of the VRF routes is being pushed to a management router, and the management router is able to tell the rest of the network how to get to the stuff. And that just makes your management life a lot easier. Because if you did have something like a VPN server, you could have an interface or something that can connect to the management router or pull routes from the management router through one of the other routers. And you'd be able to access all of your devices and manage them this way. So that is pretty cool. Let me just see any questions, guys. Yes, no, Nicola, that's exactly it. This you don't add on the backbone. This is all literally in the sense that you are creating different, let's say, instances and areas that are in a separate VRF. You're kind of going to have to do that, and then that VRF, where you're creating an OSPF instance, will then connect to a management router, but the management router, it will still have the areas and stuff, but you're not going to define any type of like VRF for it. So all of the routes will just go into the route, like the management router's main routing table. And then from there, you're able to just redistribute all of the routes across from your management router to the backbone even. So I hope this in some sense helps you ease up a bit on the management. But it's still extra stuff you need to do. Like I think I said the first time around with management networks, it's always tricky and there's always stuff you need to do. But this is its simplest iteration of just sending all of your connected routes to a management routers so you could more easily manage the devices. Okay, we did that in like 35 minutes. Maybe 30 minutes, I even say, because I was talking a bit just now. So awesome. So we did the VRRP stuff. We did the OSPF. So technically, I've done everything in the video that I've wanted to do tonight. Dudes, we even got stuff like BGP set up as well, and using the VRRP IP to create BGP sessions, which was pretty cool as well. So I'm really happy with what we've achieved and done in this video. I'm not sure if there's anything else that we want to set up here. Wolfbit, for you exactly, I want to just quickly close this lab. I'm going to update another lab or go into another lab, which is a video that I want to make. And this video is specifically like what you asked. The only issue that I have right now is due to the nature of the virtualized equipment running on EVE-NG, all of the sessions are just seen as IGP. So if I redistribute a route from this CPE, it gets to the PE just fine, but the P1 router just learns it. It shouldn't, but because the sessions are just seen as IGP for some reason, it's just learning those routes and it's making it not do what I want to show you. So I'm looking at how we can make this a bit better. But effectively, let me just quickly show you. Like, I'm still going to make the video about it. But let's close all of these windows. Wait, let's close the lab and just shut down all of the other routers on that mega lab. Otherwise, we might run into some nasty issues with a lot of resources being consumed that don't need to be consumed. So let's just quickly zoom out here, grab all of these nodes and turn them off. Stop. And this is so cool because with the labs that I'm sending to members on YouTube, the guys that are network pals, all of these routers, like this lab, except for the new stuff I need to make a new upload for, but all of these routers have like their configurations set as startup configs. So if you import this lab into Eve, like the configs are there, it's the same topology, everything's there. You can just like start working on it. It's pretty cool. I dig it. All right, let's go back to that BGP session thingy. And I did put it in MikroTik. And I think this could be a nice video, especially for me to explain instances a bit better to people, because instances do seem to confuse some guys. Like some people aren't really too sure why you need an instance and what it does and why you're running multiple instances. Okay, sorry, I'm just gonna open up the chat again. Okay, nothing new. Okay, so this is a pretty straightforward lab. The reason I closed the stuff was so that all my PuTTY windows close. So let's look at our neighbors quickly. So I've got a CP, a PE, and a P1. So what we effectively want to do with the BGP is, I'm just going to connect on here. And let's just maximize all of this stuff. So if I look at my routing, I've got BGP. I've got an instance. Its own unique instance, 64513, which is for the CPE side, which should make it an eBGP peer. Then I've got my peer to the PE, which is done correctly. And I've set all of my details here. And then I'm specifying just the network as 192.168.0.0 so that I can send this or broadcast it via the BGP. But let's just quickly remove this here so that the PE can't learn those routes. So let me open up the PE as well. So let's connect the PE. And then from the PE, let's just close all the windows. So if I look at my BGP from the PE, I've still just got an AS, but the AS is 64512, which is different to the AS on the CPE. And then I've got my peers. So I've got the peer to the CPE. And there I see what my instances are, what my remote addresses are, all that good stuff. But what we want to do now is, let's just quickly explain the redistribute bits. So here's the routing table. That's just unknown. I haven't put this in any VRF or anything. Just for the showing, you know, it should be pretty straightforward. All that we're going to do is we want to learn the routes that's on the CPE on PE1. So I also kind of did this earlier with the VRRP stuff where I was doing, but let's just do it here. So effectively what we want to do is in our instances, if I go in here with the instance, we get the option to redistribute routes. So if we set this, it does exactly what the first word says, redistribute. So on this autonomous system, if you want to redistribute, which means advertise the connected routes, we can just check it. And then effectively what happens is if I go to my IP addresses and these are the only addresses I have, but these are connected routes. If I go into my routing table, I actually think that's a better place to just describe it. If the routes are DAC, they're directly connected, then they will be sent out via this instance to my peers. So any peer that's connected to me will learn the routes. So I can just redistribute my connected. If I hit apply, what's going to happen? I'm going to add or get two routes. I'm going to get a route that says 192.168.0.0/24. If you want to get to this, then you will obviously come over this BGP. The distance is correct. Let's just look at the attributes. The attribute shows the BGP origin as incomplete. But since I'm getting a distance of 20, that is expected. That is correct. So that's how I'm redistributing connected routes. But my issue now is 172.16.0.2 or 172.16.0.0/13. I'm also learning this as BGP now. The reason being is that's the WAN link for the CPE, but it's also still a directly connected route. So this can cause potential issues, especially if there's other multiple links and stuff here. I mean, if everything's directly connected, it won't be so much of an issue, but this is where you definitely want to look at just applying some route filters. So let's add some route filters. All that I'm going to do is very basic route filter. I'm just going to call this route out or PE1. Route out to PE1. Let's just give it a good chain, a good description. And then what I can do is I can just say anything that is not 192.168.0.0/24. What do I want to happen? I want this to be accepted, or let's just set it for pass through right now. Let's apply that. And I might just have to quickly reestablish the peer. So let's just do that. Peer to CPE. And I'm still learning this route for whatever reason, which is not normal in my opinion. Let's just check my route filters. Let's just disable you, re-enable you. All right, let's just set the action to accept. Oh, but this is a pointless, this is a pointless rule actually. So anything, I should say anything that is not that I should discard. Was me being silly. So anything that's not 192.168.0.0, we will discard. All right. that looks a bit better to me. Let's just reestablish our peers quickly. Let's look at our routes. I'm still learning this route, but that's not good. All right, let's do this the old-fashioned way. Let's just set the prefix for 192.168.0.0/24. Oh, I'm so silly. I'm gonna leave it as is. I just didn't apply the route filter, so obviously this won't work. So let's just add the route filter to here, apply that, and there we go. So now we're not learning our like uplink or WAN link addresses. We're just learning the ranges behind the router that we actually want to advertise out. So that is exactly what redistribute connected is supposed to do. MikroTik, I'm not sure when they will have Wi-Fi. I think I saw a post actually on their Twitter. Let's try and find it. And Paul, hey, I'm using this is actually my gaming computer as well, but I'm using like we can look at the specs, but I'm pretty sure I'm using about I'd say 30, no, a little bit less. Let's say 28 gig of RAM, but my RAM is DDR4. I am also using a Intel CPU. Let's just do this. CPU Z. Don't I have it anymore? I swear I should have it. This should be it. So just for you, Paul, just to show you what's happening with my system. I'm not going to update anything here. So there's my specs. This is what I'm using to run EVE-NG, and I actually do quite a bit of heavy labbing, and I'm not using a dedicated server. And you can, if you've got a dedicated server for Eve, it makes it so much better. Like you can add so many different things. You could add other VMs, like other servers and services inside EVE-NG and run it as a complete end-to-end network. I mean, I've seen people use stuff like Cisco's ISE, like the ICE for authentication, and that thing is like very resource hungry, and it works completely fine. Yeah, Josh, I've also seen them have Wi-Fi 6 on Router OS 7 beta. I just know for a fact that on their Twitter, can we quickly go to Twitter? Let's just see. Sorry, I want to use some more music. Twitter. Let's just look here. MikroTik. So I don't often use Twitter, guys. I'm terrible with this. I think this is them. No, that can't be them. That's too small. Is it? There, this is the right one. Oh no, this was for the 5G that I was reading. Yeah, but I'm pretty sure Wi-Fi 6 will come out with version. But just remember, Wi-Fi 6, it has a hardware requirement as well. So it's not just like you can add Router OS version 7 on a 951 and the chipset or the wireless chip on the device doesn't support that spectrum. So just something to like keep aware of. Wow. Where did I see that? So Paul, for your question, they're both great emulators. GNS3 I used for very long. Some of my more like first videos, I used GNS3 and I had a blast, but I kept running into issues, and I think I tell this story every time on the stream. I tend to do an upgrade or an update of either VMware Player or my Windows gets an update, like my Windows operating system updates, and then my GNS3 just goes haywire. I can't do anything on it. I need to like Google stuff for a few hours and change little things, and then I can actually get it working. So yeah, my preference has shifted to EVE-NG for sure, and they've got a community edition completely free, works perfectly fine, and the setup is just nice. But if you're using GNS3, don't feel like it's a worse thing to use. It is good. I've actually seen them make good strides on GNS3 with the web UI. Drask, for me, and I've also kind of voiced this opinion about PNet Lab as well. So I'm not going to slander them or anything, but for me, it feels morally wrong to be using software that is basically it's basically EVE-NG. It is it looks like EVE-NG, it feels like EVE-NG, it is EVE-NG. It's just branded differently, and they've changed some functionality. So don't get me wrong, the functionality they've added onto it is pretty cool. I get that you can share lab images very easily. It's on a cloud almost, and that makes a lot of sense to me. I would love to see EVE-NG do that. But as for what it is itself, I don't like it, and that's why I don't like. I don't want to say endorse it, because I don't endorse anything. I'm just a network engineer teaching people how to set up BGP and stuff. But I don't use PNet Lab. I haven't tried it, and I mean the people from EVE-NG has been like super nice to me. So it makes me feel bad as a person if I even think about using something that's basically, I don't want to say a ripoff, but it mirrors what Eve is. Yeah, Nicola, yeah, it's the same for me, and I might play around with GNS3 from time to time, but I don't think I'll switch back unless they make like some crazy thing, like they do the PNet Lab thing where you can also have that functionality to have those labs just come into your client. But I'm very happy with EVE-NG, guys. Like, come on, this looks amazing. This is so nice to use, and it's so quick to set up. I mean, on the first stream of the channel, I set up EVE-NG Community Edition, I think in less than 20 or so minutes, and everything was working. We could import appliances, we could do whatever I'm doing now, and that is awesome. I've lost my train of thought now. Sorry, I think you mentioned something about adding a loopback address and then having the CPEs receive that loopback address, like a public address almost. So what I'll do is, let's just make sure I don't mess up again, because maybe somebody's going to get mad at me that I'm taking their IP address. So IP for DHCP not found. So that should be like a 169.254 address. DHCP client not getting IP address 169.254. Alright, so I can just use whatever in this pool, because last time I used like 169.255, and that is actually like a valid IP for somebody, and I don't want to use their IPs as examples because, you know, maybe somebody tries to look at their IPs and stuff, and that feels a bit awkward. This screen needs to stop, like, I don't know if you guys even see it like flashing or whatnot. Alright, but let's just do this. I'm going to add a loopback address on the PE quickly. I've already got one. Oh, but that was for the BGP stuff. Let's just create a new allo2. And then for this allo2, I can add the IP address of 169.254.88.1. And I'll add that to allo2, apply that. And then what I'm going to do is from my PE, my peer to my CPE. Actually, I'm not even going to do it here. I'm going to do it in the instances. So in my instance, I'm just going to redistribute my connected routes because a loopback address is considered a connected route. I'm going to apply that. So if I go back to my CPE, I can see that I am learning the loopback route, but now I'm learning a bunch of other routes that I actually don't want to learn. So let's just quickly also just add a route filter for incoming routes. So route in PE1. Route in, let's just call it from PE1, but you could have just made it in. I think that's pretty self-explanatory. And then we can say what prefixes are we expecting. So in this example, I'm expecting 169.254. What do I make it? 88 dot, what was that? .6 or something. .1. We'll accept that. Copy this, and then anything else we will discard. So let's just apply those filters to our peer quickly. So in my in filter, this is route in from PE1. I'm going to apply that. And if I have a look at my routing table, now I'm just receiving this 169.254.88.1 address. All right, so this is where I'm having an issue with the setup on Eve now. I don't believe this is an issue with actual routing. So for this, I might, to answer your question better, is use these little lightweight 951s. But that would be for another video, because let me show you what my issue is now. We've got the IGP here. So I've got an IGP session between PE1 and P1. So this is kind of like that diagram you sent me with the 3 routers in a line. But PE1 and P1, they are connecting on iBGP. They are connecting using the same autonomous system to get to each other. So let me just quickly close the CPE, move PE1 to the left, and let's bring up P1. So I'm going to connect to this. And what you will notice is I'm learning a route for 192.168.0.0/24. But let's just go to the config on PE1. And then from PE1, I do say I am redistributing connected. But my issue is that route, if I look at my routing table quickly, 192.168.0.0/24, that is a BGP route. And for whatever reason, it's like picking up all the way to the, oh, I'm a freaking idiot. At least I can admit when I'm wrong. I didn't connect onto the, there we go. There's the provider router. So there's the routes, but this looks wrong. I mean, the distance is all right, and I can definitely see this is a, this should be a BGP route that I'm learning. There I'm learning the route for that public address of yours. But my issue that I'm having is this 192.168.0.0/24 route. I should not be learning this. This should not be coming into this BGP session. And yet I am. So to remove that, I could add a filter as well, but That's not how this is supposed to work. Sorry, let me just open up the chat again. Okay. I've got a local pref, I've got the OSPF. All right, let's just do this. Routing. Because on the, hang on, let's quickly go on to the Discord. So there's your setup. R1, R2, R3. R1 is the edge. So R1 is not actually the CPE. The R1 is the edge actually. But it doesn't really change too much in the topology I've set up there. But what you want is routes coming into R1. You want them to be sent to R2 and R3 respectively, right? So the question that I might ask is, why are you wanting to use IBGP to redistribute these routes to your other routers? Like, I'm fairly sure it should work if I just pop up these actual physiometritics and do a quick session there. But is there any specific reason, hang on there, my other window's working again, why you want to use IBGP? Because there is a little, like, IBGP is a bit iffy. We need to understand BGP was developed for distributing routes over the internet. It's really good at that, and it's also good at like doing some stuff with services on your MPLS networks and whatnot, but you need triple PoE clients on R3 with public IPs to have internet access. Okay, so how I'm going to treat this is I'm not even going to add 3 routers here, but effectively, let's say PE1 is working as a triple PoE server as well. So your CPs could connect to PE1, and then their public IPs would be assigned via the triple PoE. I mean, it would still create them a directly connected interface on the router. And then if you redistribute stuff from PE1 to your provider network, where I assume your actual breakout and stuff is, we could probably achieve this a lot better using OSPF, which is designed as an IGP. I wonder if we can set this up here. I'd like to, but what I need to do now is stop the lab. So Wolfbit, definitely, I think in the next stream we'll continue this with this. I might actually just add a third router for, let's say, the core network, and play around with the idea of a triple PoE server on the edge assigning public IPs to the users, and then having those routes be sent across the network. All right. I think what you could also potentially do is also just use this draw.io to like give me a better picture of exactly how your stuff is kind of set up at the moment. You don't need to tell me what your public IPs and stuff are, obviously. You could give me dummy IPs, and then we can try and find a way to either replicate that on the lab, or I might have to bring in some of these physical MikroTiks just to figure it out. But for the most part, guys, I am going to call the video now. I'm going to call the labs, or call it a night, because I am also still pretty spent, and I actually only plan to cover the VRRP and the OSPF topics, and I feel like we did that quite well. So I'm not going to go any further tonight, but we will definitely carry on in the next stream, especially with the topics you're bringing up now. Guys, if you do have other questions, please feel free. I can't say message it here because the messages might not show up, but pop it on the video afterwards, or go to the Discord, pop it on the Discord. I do read the stuff. Maybe sometimes I don't reply, but it's not because I don't like care or anything. It's just I get busy, I read it, and then I figure this stuff out afterwards, and then bring it up on the stream like now. Anyways, guys, hope you have a great evening. Thanks so much for watching. Appreciate it so much, and I want us to just keep growing, learning together, become the best network engineers that we can be. So peace out. Bye bye. Ooh.